Okay, so for problem number 29, it says a coil in a 60 hertz circuit has a resistance of 100 ohms and an inductance of 0.45. Calculate the coil's reactance and the circuit's impedance. So I think they're talking about inductive reactance, right? So that's part A. Let's do that first. So one relationship is 2 times pi. What else did they give us? They gave us a frequency, right? That's a frequency. And then they gave us the inductance right here. So yeah, okay, good. I can calculate it with that. So I just got to take those numbers and plug them in. So I've got 2 times pi times the frequency, which is 60 hertz, times the inductance, 0.45 Henry, and all of that stuff. If you plug that in a calculator, should give you an inductive reactance of 1.7 times 10 squared, or not times 10, yeah, well, yeah, 1.7 times 10 squared ohms. Okay, so good, that's good. Now for part B. Part B says, what is the impedance? Oh, okay. So remember that impedance is going to be the resistance plus the inductive reactance minus the inductive capacitance, right? Or not, I said that wrong. Capacitive reactance. You know what I mean. All this stuff squared. All right. So there's a little trick to this one. The resistance is 100 ohms, so we're going to put 100 ohms here. Boom. Plus. Now here we just calculated this, so this is 1.7 times 10 squared of that. Oh, let's put that on the end though. And then I'm going to assume, oh yeah, because it's a coil, that the capacitive reactance would be 0, right? And so all that stuff, and the unit for that is ohms. So I'm going to write, well, we'll say this is squared and then just ohms squared. I'm just going to pull it out of the thing, which is fine because when I push it back in, then we'll be, when we take the square root. So the impedance is really the resultant vector of these two vectors. If you do all the math, what did my notes say? I think you've got 100 plus 170 squared. My notes say 2 times 10 squared ohms. So it's probably about 4,000. What do you think about that?